Hey guys, so today we're going to be solving this problem, which is find the real number a, which satisfies both equations, then find the function. So when it says find the functions, it's basically asking us to find f of x and g of x. So let's read the functions. The equation. The first equation is integration 1 to x of f of t dt is equal to x times g of x plus ax plus 3. And the second equation is g of x is equal to x squared plus x integration 0 to 1 f of t dt plus 1. Now this was a tricky problem, so I encourage you to pause this and give this problem a go. And then after that, you can come back, check your answer, or if you don't know where to start, I will go over the solution. So pause the video right now if you want to give this problem a go. Alright, so we're supposed to find a and the functions f of x, g of x. So we can only find these functions once we find a. So let's make finding a our topmost priority, right? Because when we find a, we can easily just substitute and we can find f of x and g of x. So how do we find a? Well, let's first assume that this is equal to k. So if we do that, that's saying, let's assume that integration 0 to 1 f of t dt is equal to k. This means we can rewrite g of x in terms of k, right? That's basically saying g of x is equal to x squared plus xk, because remember this is k, plus that one. Now this is g of x in terms of k. We see that in the first equation, there is a g of x in there, right? So let's try to substitute this g of x into this equation. So if we take this, that's basically saying integration 1 to x f of t dt is equal to x times g of x. Let's replace g of x for this. So that's x squared plus xk plus 1 plus ax plus 3 plus ax plus 3. Now you see we have g of x in terms of k and this equation in terms of k and a. So we've introduced a new variable k, which we have to find out later. Don't forget that, but never mind that right now. Let's just focus on finding the value of k, which was our main goal, our first main goal. So let's try differentiating both sides with respect to x. And in some of my previous videos, I explained how to take the differentiation of an integral if it's if it's b to x, where b is simply any number. And I'm just going to go over that right now since we are going to be needing that theorem/formula to find the derivative of this. That's basically saying integration b to x of f of t dt, well, the integration of this. Actually, let's just do this. If, let's say, r of x was equal to this, then r prime of x is equal to f of x. That's it. It's just equal to f of x. Just replace x for that t. Only when you're differentiating, though. Don't do it when you're just solving the integral. That's completely wrong. Just only when you're differentiating. Only when shading. Hopefully I spelled that right. But remember, this is only true when you're differentiating, not when you're solving the integral. And here we can apply this because we are differentiating both sides. We're not solving this integral, but we're differentiating both sides. So then if we differentiate both sides, let's replace that t for x. So we get f of x is equal to, we should have probably simplified this, shouldn't we? So let's just rewrite the left-hand side as it is. And then let's expand this so we get equals x cubed plus x squared k plus x plus ax plus 3. Now we can differentiate, so we can say differentiating both sides. with respect to x, this would be f of x, because once again, from this theorem, is equal to 3x squared plus 2xk plus 1 plus a. So now we have f of x. That's good, because we saw that here we have f of x, and over here we have g of x, so we're getting close. But here we have that a. We still haven't figured out what the value of a is. But not to worry, we see that when we assumed k, it was in terms of f of t, and this is f of x. So let's replace this f of x in here. So let me just copy this. And now let's start replacing it. So that's basically saying f of integration 0 to 1 of f of t, replace everything with t, so that's 3t squared plus 2tx plus 1 plus a dt equals k. Integrating this, we get t cubed plus t squared k plus, sorry, my mind glitched, plus t plus at, and then 0 to 1 equals k. Let me just do this. Now let's replace 1 in here, so we get 1 plus k plus 1 plus a. If we just replace 0, we get 0, so I'm not going to do that. Then we do 2 plus k plus a, just simplifying it, equals k. We can cancel out this k, and we're left with 2 plus a is equal to 0. Therefore, a is equal to -2. That's good. We found the value of a, so that's one step done. But we still need to find the functions f of x and g of x. So first, since we found the value of a, let's replace a and for -2. So once we do that, we get f of x is equal to 3x squared plus 2xk plus 1 minus 2, which is just -1. Now we have found f of x, and we see that f of x and g of x are both in terms of k. So now let's try to find k. And now when we find k, let's not try to introduce another variable, otherwise we have to find the value of that variable, and that would be just too much. So instead, let's take a look at this. We use this, yes, I agree on that, but let's try to see how we can use this once again. So I've copied that over here, and we see it's in terms of g of x, right? And we know g of x, it's in terms of x, but it's in terms of k, but nonetheless, we still know what g of x is equal to. Now, this is the crucial part. We know that integration of 1 to 1 of f of t is simply going to be 0, right? Because you're practically not covering any area, so the area is just going to be 0 underneath that curve, no matter what that curve is. So that's basically saying x is equal to 1. That's basically saying x is equal to 1, right? So if we replace x is equal to 1 on the left side, we have to replace x is equal to 1 on the right side. That's basically 1 times g of 1, which is just g of 1, plus a plus 3. G of 1, we saw g of x is this, so let's replace g of 1 here. We get 1 plus k plus 1, which is just k plus 2. K plus 2. We know a. A is -2, so -2 plus that 3. This is equal to k plus 3, and we know this area is simply just 0, so 0 is on the left-hand side. Solving this, we get k is equal to -3. So we found k, and we found a. Let's start replacing them in the equations we found. This was the f of x equation. This was the g of x equation. This is basically f of x is equal to 3x squared, k is -3, minus 6x minus 1. This is f of x g of x is the same procedure. G of x is equal to x squared. Once again, k is minus 3, so minus 3x plus 1. And we are done with the problem. We found g of x, and we found f of x, not in the terms of a and k, but it's actually a function. And we did so by first finding a, then we had to find k, right, because we introduced the k in order to find this a. And once we found a and k, it was just a matter of substituting them in these equations. So thank you for watching, and I'll see you guys next time with a new problem.